In the sixth video of mine, we will be discussing about soil reinforcement under ground improvement techniques. Soil reinforcement. A weak soil is reinforced by high strength material, composition material, compacted frictional fill and linear soil reinforcement. Forms of soil reinforcement: stone column, compaction piles, soil nailing, micropiling, earth anchor or rock bolts, strip and membranes. Major function to increase the load carrying capacity of the soil, provide stability to soil masses for construction over. Basic requirements are durability, resistance to corrosion, non-biodegradable. The material used should be a non-biodegradable item. Long life. Preferred material: high alloy steel, aluminium, glass fiber reinforced plastic, geosynthetic. Civil engineering application where soil reinforcements are used: rails and railroads, airfields, embankments, retaining structure, reservoirs, canals or dams, bank protection, coastal engineering, etc. Reinforced soil retaining structure. Approach road of a bridge. It is very commonly seen when the approach road of the bridge is constructed, soil reinforced is being used over a bridge or a flyover. State of the art flexible system. Success development in geosynthetic. Advantages: cost effective, tolerate large settlements, less installation time, less hindrance to traffic flow, handles poor soil condition. This is a perfect example of an approach of a highway or approach of a flyover where soil reinforcement is being carried out. The construction sequence will be discussed further. Construction sequence of soil reinforcements are as follows: subgrade preparation, placing of leveling pad, erecting of fascia blocks, placing backfills and geogrids, then having compaction done, construction of site curbs and pavement. This is a typical photo of a geomembrane or a geogrid used in soil reinforcement. As you all can see, this is a flyover approach which is being constructed. The soil is being dumped and now geogrid membranes will be placed to increase the tensile strength and the bearing capacity of the soil so that the road can be constructed over it. Subgrade bearing capacity should be of 8 ton per square meter, foundation at least 450 mm ground, erection of fascia, soft backfilling, reinforcement. Tonge and groove arrangement is done, flexible geogrids are used, reinforcement is pulled and anchored between the fascia blocks, compaction to achieve 85 proctor density should be done, reinforcement is placed with 2 to 3 of OMC, smooth wheel vibrator roller is been done used, 1.5 near fascia vibrator compactor is used. Geosynthesis, polymer products used for soil treatments. Material used are polyester, polyethylene, polypropylene, polyvinyl chloride or famously known as PVC. Type of geosynthesis: geotextile, geogrid, geonet, geomembrane, geocomposite, geosynthetic clay liners. Geotextile on the first, geogrids on the second, which we saw on the previous slides also, geonets, geomembranes, geoclay liners, geofoam, geocomposites. Major functions served: separation, reinforcement, filtration, drainage, contamination. This is a comparative chart of geotextile, geogrid, geomembrane, geocomposite against which is better for separation using or reinforcement or filtration or drainage or contaminate. Geotextiles, flexible porous fabrics. Textile consists of synthetic fibers, porous across the manufactured plane and also within their thickness, manufactured from polyester or polypropylene. Geogrids possess large openings. Types: punctured geogrids, HDPE or polypropylene, woven coated geogrids, high tensile in strength and stiffness, mostly used in reinforced material. Geonets, made of crisscrossing polymer strands, biplanar, 2 layers of strands, triplanar has 3 layers of strands. Geomembrane, thin material, relatively impervious sheets of plastic, may be strengthened with fabric. Primary function: sealing against fluid percolation, buffer against pollutants. Geopipes, flexible plastic pipes used in highways and runways. Geocomposite, combine the feature of various geosynthetic, can be combined with other synthetic or non-synthetic material, plastic sheets, steel cables, even with soil. Drainage geocomposites, blanket drainage usage, edge drain usage, wick drain usage, sand wicks. geosynthetic clay liners GCL, sandwiching bentonite clay between geotextile or geomembrane. When wetted, the clay swells and acts like an effective hydraulic barrier. In this sixth video, we saw the various methods of soil reinforcement used under ground improvement technique. The major learning from this sixth video should be the various geosynthetic and geomembranes which are used in soil reinforcement to improve the bearing capacity and various other characteristics of the soil. Thank you and Jai Hind.